All right, welcome to your screencast for Investigation 4B, Sediment from Land to Sea. I've retyped this and simplified it a little bit, but it's adapted from the American Meteorological Society's Ocean Studies Manual. And so what I did is I took out the parts that didn't really pertain to what we're doing in class and shortened it a bit. But anyway, that's where this comes from. And because you guys are 8th graders, sometimes these lab investigations are written at a level that I feel like is a little bit above 8th grade, so I like to go through them with you so that you make sure that you understand everything that's being said and being done. So here we go. For this, whatever I write, you write. Whatever I highlight, you highlight. Whatever I do, you do. Also, it's essential that you actually pay attention and follow along rather than just flipping through the video, because there will be some times that I ask you to do something on purpose that you don't see me do, just so that I know that you are actually paying attention. All right, so let's get started. Lithogenous sediments formed mostly by the weathering and erosion of pre-existing rock are the most abundant of all marine sediments. Most lithogenous sediments are delivered to the ocean by rivers and streams. The overland flow of water during and following rainfall or snowmelt delivers sediment to rivers and other drainage ways that ultimately empty into the ocean as part of the global water cycle. All right, so we're going to dissect this first paragraph and go through so that you understand what everything is and what it means. All right, so the bold, lithogenous sediment, that is just simply sediment that is made from broken down rock. Litho is a word part that means rock. Gen is a word part that means beginning, as in like Genesis, the beginning of the Bible. And I want you to go and highlight this sentence that says most lithogenous sediments are delivered to the ocean by rivers and streams. Okay? So, and I do want you to write in what is lithogenous sediment made from broken down rock. And over here in my notes, you're going to add litho is a word part for rock and gen is a word part for beginning. I'm going to show you all of that in just a second, but just to make sure that you're paying attention, please draw a little tree out to the left of the word lithogenous sediment. Okay, so other than the fact that mine has a stamp on it that says received and it says 5th period, yours should now have that one sentence highlighted, and you should have circled lithogenous sediments and written down that it's sediment made from broken down rock, and that litho means rock and gen means beginning. Also, remember that there is something that you should have drawn out to the side of lithogenous sediment. All right, we're going to go on to the next couple of paragraphs. Okay, after completing this investigation, you should be able to explain why rivers differ in their sediment load delivered to the ocean. Lithogenous sediment transport. So I'm reading the first paragraph. Rivers and streams transport the products of weathering and erosion on land, meaning rock and soil particles, via suspension, solution, as well as bedload. Via, like by way of. What method are they transporting? Well, there's 3 methods: suspension, solution, and bedload. Bedload means that the rock or soil particles are pushed along by the current along the channel bottom, along the river bottom. In general, the size of a particle and the speed and turbulence of the river water determine whether a particle is carried in suspension or sinks to the river bottom. With increasing current velocity, the flow becomes more turbulent, and a river can carry larger particles in suspension. Conversely, a very fine set of particles may be suspended in seemingly stagnant water. Stagnant water means water that is not moving at all. When a river enters the sea, the current diverges and weakens, and particles begin to settle out of suspension, sinking to the sea floor. Okay, so let's deal with this paragraph and do some highlighting as well as some additional notes. Okay, so looking at the paragraph under lithogenous sediment transport, I want you to highlight where it says rivers and streams transport the products of weathering and erosion on land via suspension, solution, as well as bedload. Also take your highlighter and highlight the sentence that says, in general, the size of a particle and the speed and turbulence of the river water determine whether a particle is carried in suspension or sinks to the river bottom. And then also highlight, with increasing current velocity, a river can carry larger particles. Okay, then I want you to also add out here to the side, rivers transport sediment in one of three ways. Number one, suspension, meaning that particles are carried along by the river itself, like within the river water. Number two, solution, meaning that particles are dissolved in the river water, kind of like sugar gets dissolved in water when you make Kool-Aid. And number three, as bed load, which means particles are basically tumbling along the river bottom and moving that way. Okay? There's another important thing that's mentioned in this paragraph, and that is down here, that greater water velocity means the river can carry larger particles. So the faster the river flows, the larger the particles it can move. Okay, so make sure that you've added all of that. Also, just to make sure that you're listening, by the heading where it says lithogenous sediment transport, put a little star. All right, and join me in just a second when you have had a chance to write all the notes in. Okay, so now we're down towards the bottom of the page at the next paragraph. The type of particles delivered to the sea by rivers depends on the climate, geology, topography, soil type, vegetative cover, and human activities in the drainage basin. A drainage basin is the fixed geographical region drained by a river and its tributaries. For example, plant roots anchor the soil so that a drainage basin with extensive vegetation yields less sediment to rivers than a drainage basin that has less vegetative cover. Okay, I'm going to show you what I mean by a drainage basin in just a second, and I'm going to show you the Mississippi River drainage basin. Okay, so you've got most of the continental United States in view, and you can see that this whole entire area ultimately drains into the Mississippi River and empties into the Gulf of Mexico. Okay, the red area drains first into the Missouri River, but then the Missouri River joins with the Mississippi. This kind of fuchsia area, that's the upper Mississippi River Basin. This is the Ohio River Basin, but again, it eventually joins with the Mississippi. The yellow is the lower Mississippi River Basin. The green is the Arkansas and White River Basin, and then the light blue is the Red River Basin. Remember that the Red River forms part of the border of Texas. But all of this joins at some point into the Mississippi River and empties into the Gulf of Mexico. So this whole area is the Mississippi River Drainage Basin, and it covers a large portion of the continental United States. So water, rainwater that falls in any of this, anywhere in this area, if it's runoff, it will ultimately wind up in the Mississippi River. Okay, so let me show you what I've got so far for this particular paragraph. All right, I've highlighted where it says the type of particles delivered to the sea by rivers depends on the climate, geology, topography, soil type, vegetative cover, and human activities in the drainage basin. So highlight that sentence. Also highlight the next sentence that says a drainage basin is the fixed geographical region drained by a river and its tributaries. Remember, we looked at the Mississippi River drainage basin, and just to make sure you're listening, why don't you write out to the side Mississippi River. Also down here, this is a reminder of part of what was said in the paragraph. Areas that have more vegetation, more plants, have less soil erosion, and therefore less sediment is going to wind up in the river. So less sediment is transported by the river. So if you've got a lot of vegetation, that tends to hold on to the soil better, and there's less soil erosion and less soil winds up in the river. Okay? All right, in just a second, we're going to go through the first couple of questions. All right, number one, as a river enters the ocean, its current diverges and slows. First of all, highlight that sentence. The first particles to settle out of suspension are they going to be small or large? Well, up here, it says that greater water velocity means that the river can carry larger particles. Well, if the river slows down, the first particles that are going to get dropped are the ones that are the largest. So the first particles to settle out of suspension are relatively large. So circle large. Hence, meaning therefore, the coarsest or finest sediment carried by the stream is found on the sea bottom closest to the river's mouth. Okay, if large particles are being dropped first, they are going to be dropped closest to the river's mouth. The smaller particles will be carried further out, if we're talking about the Mississippi, further out into the Gulf of Mexico or something like that. So, number 2, the coarsest sediment carried by the stream is found on the sea bottom closest to the river's mouth. Coarsest means largest. Okay. Number 3 says, compared to rivers and streams in a relatively flat drainage basin, rivers and streams flowing in a mountainous drainage basin have steeper gradients, flow faster, and can transport, which one, smaller or larger particles to the sea? Well, if it flows faster, remember, greater water velocity means it can carry larger particles. So number 3 can transport larger particles. So circle larger. Okay. All right, number 4 says the rates of chemical weathering, decomposition of rocks, generally increase with rising temperature. Consequently, with other factors being equal, a river in the tropics is likely to transport what? A greater or lesser sediment load than a river located at high latitudes. Well, first of all, let's make a few notes about what they've just said, and then we'll answer the question. Okay, so first of all, it pointed out that high temperatures equal more chemical weathering. So you're going to have more chemical weathering at higher temperatures. And also a reminder, tropics means hot weather. So tropics is hot, and because you have higher temperature in the tropics, you're going to have more weathering. Okay. So all other factors being equal, a river in the tropics is likely to transport greater or great sediment load than a river located at high latitudes. Okay. Number 5, regions of monsoon climates, for instance, India and Southeast Asia, have distinctive rainy and dry seasons. The rainy season is in the summer with high sun, and the dry season is in the winter with low sun. All right, so first of all, we here in Texas do not experience monsoon climates, okay? The areas that do, basically they have a rainy season and a dry season. Their climate is not so much a big temperature variation as it is a variation in the amount of rainfall that they're getting, okay? And it does say that their rainy season is in the middle of the summer and the dry season is in the winter. So, all other factors being equal, we would expect greater sediment input into the ocean by rivers during, well, it's going to be during the summer when it rains a bunch, which is when the runoff is going to occur and we get more water transported into the rivers and into the oceans. So number 5 should be summer. And again, this is with monsoon climates. This is not here in the United States with us. Okay? All right. I'm going to end this screencast and join me for the second one, where we're going to start talking about Table 1.